Welcome. We're going to be talking about HMS networks and their smart interfaces for HVAC control, the way to energy efficient buildings. Our speaker is Aitor Hernandez, product manager for AC Interface. Now, with the energy consumption monitoring and optimizing the HVAC systems, HVAC control interfaces can be a game changer in building energy efficiency. So we're going to explore some real world data as well as success stories. We're going to show how these interfaces can transform building users' comfort and their well-being, as well as saving energy costs. So to create a greener and more sustainable world, let's join this opportunity to delve into the future of HVAC control, the most important factor for energy efficient and sustainable buildings. Aitor, all over to you.
Nice to meet you, everybody. As Bob said, my name is Aitor Hernandez from HMS Networks. I'm based in Spain. And yes, I will talk a little bit, about 20 minutes, about energy saving in HVAC systems in building automation. So this is the agenda for today. I already did my presentation. I will talk a little bit about HMS Networks and AC Solutions brand, let's say. Okay. I will talk about energy management in buildings. I want to do a little overview about how is the actual situation of the HVAC systems in buildings related to energy consumption, of course. And I want to present you two solutions that we have right now to reduce this energy consumption in buildings. The first one will be solutions that are directly connected to the indoor unit. And the second one, the most powerful solutions for outdoor unit connections. With a single gateway, we can control and monitor up to 128 indoor units. Okay. I want also to save a slot for 5-10 minutes if some questions arise. Okay. Let's talk a little bit about my company, about HMS Networks. Okay. I should say that our actual company name is Intesis, but we were merged with HMS Networks 5 years ago, something like this. Okay. Our main market is to create connectivity for AC solutions from all the major brands of the world. Okay. It's simple, but it is not. Okay. Our main products are AC interfaces. As I said, two kinds of solutions. First one for one-to-one indoor unit connection. The second one for outdoor unit connection. Okay. Right now we have more than 1 million connected AC units globally, according to our market numbers. All of our devices have been developed in stretch collaboration with AC manufacturers. Okay, it is important to know that the way that the gateway communicates with the AC units, it's always confidential. Okay, so we need to be in touch or in collaboration with those AC players in the world to get these protocols. We support different types of VMS systems. In that case, we will talk about KNX. Okay, that is its main market here in Europe. Okay, and of course we have substantial energy saving achieved by those kind of AC systems. Okay, I will detail all of these features later. If we talk about brands, about manufacturers, what we are integrated with, mostly all of them. So let's see an overview about how the HVAC or how about the energy efficiency can be applied to these HVAC systems. Okay. Right now, it's easy. In the world, 40% of energy consumption is due to buildings. Okay. 40%, it's too much. That's it. About 1 0 to 30 feet of the gas emissions are also due to buildings. Okay. If we focus on Europe, okay, data is almost the same. It's about 40% and 36% of CO2 emissions, okay? And it is important to know also that 35% of the European buildings are over 50 years old, okay? So we are not only talking about new installations, so we are talking also to retrofit installations, okay? 75% of the buildings is energy inefficient. So no control system, no monitor system there. HVAC systems works alone, okay? If we focus on buildings, we can get then almost 45% in the buildings can be, is actually input to HVAC systems. 45% again is too much. So we need an efficient way to manage all of these HVAC systems. Okay, of course, this 45% is due to cooling and heating. Okay, we have detected that cooling is fast growing over the world due to climate change. Okay, so it's the most consuming application within buildings right now. Okay, the market is growing so fast, so over 100 million aircon units are installed every year. What is the best way to reduce this energy consumption, or to at least monitor and control this energy consumption there? So it's what I say, the building automation wheel, okay? That it's control, it's monitor, it's do maintenance according to this monitor data that we get from the HVAC units. With this maintenance, we can get statistics, what is not working well within our HVAC system, and of course, do an efficient use with all of this data, okay? And of course, the wheel starts again. Our customers report energy savings between 20 and 45% using our interface and using a VMS system, okay? 45% with the number that I talked about, it's a lot of money. It's a lot of efficiency. I will talk about our solutions. I split here into two parts, the indoor unit solutions and the outdoor unit solutions, okay? Indoor unit solutions are devices that are connected directly to the indoor units, okay? We can both control and read data from these indoor units, and we will inject this data into KNX, okay? Our devices, they have also binary inputs too, as you can see here in the image. And these binary inputs can be used to reduce consumption. For example, with window contact sensor, okay? If we connect a window contact sensor, we can basically shut down the indoor unit automatically, okay? It seems simple, but most of the units installed worldwide do not have this feature, okay? We can also read data from occupancy sensors. Several AC brands include occupancy sensors in their units, okay? So we can get this information and we can control or do some action to avoid maybe to stop the indoor unit when there's nobody there, okay? Related to maintenance, we can access to all error codes, okay? There are a lot of error codes in those kind of machines, and we can act according to the error code. For example, we can get overheating error code, and we can decide to stop or to perform a set point action in the unit in order to reduce or stop this error code, okay? And of course, we have the set point limits. It is very normal that people in the room try to go up set point to high limit. Okay, for example, it has no sense to set a 32 degrees Celsius in a room, so we can control and read those limits in order to block this functionality for the final user in the room. Okay. If we talk about older unit solutions, it is a little bit more complex. With these kind of systems, we can control up to 128 indoor units together. Okay, as we know, there are VRF systems. Okay, we have developed this year in May 2023 a new solution that it's called 700 Series Air. Okay, this solution was developed according to requests from customers, historical customers that we had over the years. Okay, this is a complete new hardware design with long-term microcontroller inside that ensures availability for upcoming years. As you probably know, I think everybody has experienced lack of components due to war, due to COVID, etc. Okay, we decided to modify a little bit our old generation gateways to include more AC ports together within the same hardware. Okay, that means that you can control different AC brands within the same hardware. For example, KNX distributor only needs to store one reference, despite of the final AC brand that he will integrate. Okay, we are ready to be sold worldwide. Okay, we have certifications for all countries. We have 3 binary inputs. This is a very high novelty and is very related to energy saving. I have a few slides later to talk about it in detail. And we are IoT ready. We are including maybe next year MQTT support to get this data from the AC and inject it to the cloud through internet. Okay. This is the main schematic or main wiring diagram for our gateways. Okay, as I said, we are connecting our gateway through the outdoor unit. We have 3 indoor units here, but we can control up to 128 or 64 or 16 or whatever. Okay, we are getting all of this data here and are passing data to the KNX system. The main difference within those systems and the one-to-one or indoor unit direct connection is that we can also get data from outdoor units. Okay, that it is important for maintenance. We can get data from pressure on the compressor of the outdoor unit or internal temperature values there or whatever. Okay, we can, through these systems, also access to enable occupancy sensors from each indoor unit. Okay, we have also access to error codes, more error codes than one-to-one. For example, we can receive an alarm for the filter change or whatever. Okay, that can cause inefficient with work. Okay, and of course, we have energy meting features with pulse meters by using those binary inputs here. Okay, this is the main novelty according to energy saving purposes that we are introducing with this kind of systems, and I have a few slides to talk about. As you probably know, in an AC systems, we have, let's say, 2 elements. The first one is the outdoor unit here. The second one is the indoor unit here. Of course, both of them are consuming energy. Okay, we have some fan maybe here. We have vanes. We have normally an LCD screen. But frankly speaking, the most energy consumption is due to this big element here. Okay, this element here is the responsible for cooling and heating. Okay, it's actually this consumption here, it's another scale from the consumption here. Okay, so what we want to do is to detect how much of this energy consuming here can be assigned to each tenant here. Okay, it is not a simple issue because it is the same element that is working for each tenant. Of course, all of these tenants can be demanding energy together. Okay, so it is not just a division. Okay, and we have to say that it will be always an approximation. What does it mean? That it cannot be used for billing purposes. Okay, we will get a number. We have 1 kilowatt hour here, a half kilowatt hour, 0 and 0. We cannot use this data for billing, for money. Okay, it is important to know. Of course, this division has been validated with each AC manufacturers. Okay, it is not an algorithm that HMS has invented. Okay, all of the algorithms used for each AC manufacturers have been validated. Okay, and this is more or less the wiring overview what we are talking about. Okay, we have, for example, 3 outdoor units here, 1 pulse meter connected to each outdoor unit. We have up to 3 binary inputs here, so we have 3 pulse meters. In this example, we have only 3 units, but we can have up to 64 units here together. Okay. This is the result. So we will create a signal for each indoor unit with the consumption yesterday, today, and total, the accumulated. Okay. Of course, this consumption here is get according to these values here. As I said, up to 3 pulse meters can be connected to binary inputs. We can also use Modbus TCP meters instead of pulse meters. It depends on installation, on the topology, and so on. Let me go into the summary of what I talked about today. Important things that I want you to maybe retain. So buildings use about 40% of global energy. If we do simple maths, 80% of energy consumed in the planet is due to cooling and heating. Okay, I'm not talking about real energy related to buildings. All the energy in the planet, 18% is cooling and heating. So as you probably think, it is very important to control and monitor these kind of AC systems that are consuming huge amount of energy. Okay, the energy savings are about 20-45% using efficient VMS control systems. Okay, we are talking about our gateways, but we can talk about all the gateways. But it's important to know that it's necessary, it's mandatory to control those kind of AC systems. We are saving energy, we are saving money, and we are saving the planet, actually. Okay. Let's talk about me. Entities or HMS has more than 20 years of experience doing this kind of things. Okay, we have a lot of experience with this kind of protocols by to communicate with indoor units, to communicate with outdoor units. We have a lot of NDAs, a lot of agreements in place with most of AC manufacturers in the world. Okay, and last but not least, our specific features. As I said, we have a bench of specific features just for doing it. Okay, most of those features have been developed according to customers' needs, according to market needs, or according to our experience. Okay, we're talking about binary inputs. We are talking about using mounted occupancy sensors in the indoor units, and we are talking about energy metering or power proportional distribution in other units. So that's all for my part. If there is any question.
I'm very impressed by the 18% of all energy in the planet. So thank you for sharing that. But I would like you, if you wouldn't mind, because when you're talking about the 700 series,
Yes.
you did mention that it was IoT ready.
Yeah,
And
it
I
is.
thought maybe you could take a minute just to explain the significance of being IoT ready and how that
Yes.
works.
When we talk about IoT, we talk about inject data to the cloud. Okay. There are actually several ways to be IoT ready, and there are actually several ways to integrate devices into the cloud. Okay. It has been a decision in the company because there are a lot of protocols, there are a lot of there are these people that integrates its own cloud in the system, and we decided at first approach to the IoT world to add MQTT technology to our devices. Okay, MQTT is an open protocol. We are providing this data to the cloud, and the customers can consume or subscribe to this data by their own with their own cloud solution there. Okay, it's just let's say a way to provide this data to the customers via IoT. Okay.
But thank you for joining us today. I appreciate you being here.
Thank you. Thank you for your hosting.